panellists for today's webinar are Bojana Graham from Wesley College in Melbourne, who's very experienced in both using the IB and the TI-Nspire, which is a T-cube instructor, and has presented at many conferences locally and internationally. The second panellist is Russell Brown, educational consultant from Victoria with vast experience for more than 20 years using Texas Instruments calculators. And Russell really is one of the gurus. If you have questions, he's the man I'll often turn to. During today's webinar, you'll be seeing the presenters' desktops. You can communicate with presenters using the chat space. Now, I recommend you communicate to all panellists. That way, everyone can get your questions during the session, and we'll be able to give you feedback to your questions, hopefully, during this hour. And if we don't, we'll get back to you within a day or so, answering any questions you may have. Tonight's agenda with the IB exam readiness, we're looking at the introduction, press-to-test settings, statistics, probability, Poisson and continuous complex numbers, volumes of revolution, normal probability, finance, and chi-squared distributions. Again, during the webinar, don't forget the Q&A and the chat space that can be found on your floating toolbar. Remember, to all panellists if you want to communicate. You can type your comment here and send it to, don't send it to the host, actually choose the all panellists. Now, we'll get started and we'll transfer the desktop across to Bojana, who will start off the session, and then we'll move on to some Russell stuff. Thanks very much. I hope you enjoy the session.
Good evening, everyone. I hope you will be able to see my desktop shortly now. So I will start with general information about press-to-test mode because that's really important for the students to have it set correctly. We're working with the latest operating system 4.00, which has the advantage of showing the angle mode, whether it's degrees or radians, and that is quite important. When students set the calculators in press-to-test mode for IB purposes, they need to untick or uncheck 4 options. Inequality graphing, they are allowed that. Uncheck limit trig functions because they should have access to trig functions. Untick disable log template and summation so they can use sigma function and or log, and also they have access to polynomial root finder, simultaneous equation solver. The angle setting can be changed later, but for study students they only use degrees, so it is advisable they start with degrees. Standard level and high level should start in radians. They only use degrees with trigonometry questions, sine, cosine rule. Otherwise, they mainly for graphing and everything use radians. But this setting can be changed in press-to-test mode, both in graph screen and accessing the setting for the documents. Also, float and angle in graph screen can be changed. Press-to-test can be transferred with correct settings between handhelds using the link cable as well, because sometimes students forget what to untick, so that's one of the things they can do. And also later they can drag exit test mode if they have the software on their computer. Now, they should put the calculator into press-to-test mode just before entering the examination room to save battery and make sure that no documents were created, because that's not allowed. Now, main features using the calculator in Nspire examination. Study students have the calculator for both papers, standard level, high level only for paper 2. So these are the main features which I have listed. Now, there is no access in the graph screen, the equation mode to equation, so they can't draw vertical lines or access equation of a circle, ellipse, and so on. And there is no access to differential equation in graph screen. Otherwise, all the features of the TI-Nspire non-CAS are there for them, like numerical derivative and numerical calculus, complex roots, all probability distributions, and all statistics. Plus, they have numerical solve and polyroot finder. So I will quickly go to the calculator now and show those quick few things. So as I said, radiance is showing here, and in our algebra we have three main features: numerical solve, solve system, and polynomial. Roots, which has two features. Numerical solve is good if we have two one-to-one functions, but in other cases, as I will illustrate now, if I solve a quadratic with the straight line, so I will only get one solution. So it gives the solution closest to 0. I could do a trick and, let's say, put another number here past x, let's say 2, and then I will force the calculator to give me the other solution. And now there is only 2 for a quadratic and straight line, but it is not ideal using the numerical solve. It's more advisable to sketch it. So other features I mentioned in algebra, we have solved system of linear equations. We can have 2 or 3, and we can change the variables if in a particular context they are different, and it is an easy way to enter the equations equals 3, let's say, and A plus B equals 1, and they get the answers as fractions. So that's available in press-to-test mode as it shows. And the last one, we have polynomial tools, and we can display it in 2 ways. If I go 1, it displays degree, and then they need to actually enter the coefficients properly. But we can also have it unsimplified if they use polynomial tools, but we go real roots of the polynomial. That allows us to actually enter the equation unsimplified, because the other one we had to have the coefficients known in front of x squared or the highest power and so on. So here we can actually do that, comma x, and it gives the roots. If they are not exact values or fractions, then of course only as numerical values. So that is available, and they can find complex roots as well. More in the calculator screen, we have a complex number tool, and we can get conjugate, polar angle, magnitude, and convert. So now, depending on which settings we are, if I go 1 plus, we have to use I from here, plus I, and we go menu, and we go number, and I want to convert to polar, and because I'm in radians, I will get modulus here and the angle in radians. However, if I change the setting to degrees and do the same thing, then I will get a different display. We can also use modulus if we want from here, not going to the modulus, and we can just go 2 minus I, and the calculator will get those features. So that's quickly in the calculator screen. Now if I get the graphic screen, we have all the features available. So we can draw the tangent. So let's say if I quickly enter x squared e to the power of x, and I want to hide that, might get a bit zoom in. And if we go to geometry, points and lines, tangent is available as well. So I need to say graph, and then I need to open the left bracket and get the x value, and the equation of the tangent gets displayed. with giving the equations. However, in menu here, if we go to graph entry, equation is not highlighted, so it's disabled, and differential equations are disabled. Trace still works, so I can put any point there and I can get the values. It is particularly useful if we want the asymptote, so let's say I have 2 over x minus 1, and if I use trace, students can check that when x equals 1, it actually shows it is undefined, so that is the asymptote. So these are the features, and also, as I said, because in IB we need 2 decimal places, so let's say if I sketch a graph, want to find the point of intersection and get the intersection from there to there. Oh, that didn't work very well. It's too easy because that's the whole point, but we can still change in setting the float. Of course, in this case, it will not work, but later we can see, and it would display more if I, let's say, change that to something else, which is not that simple. So this float can be displayed as well. So that is the general things which are available in press to test mode. And now I will transfer to Russell, and he will show us how we deal with statistics. Thank you.
Thank you, Božena. We have to travel a long distance here, so our desktop takes a little bit longer to come up on the screen. We're going to have a look at a couple of statistical determinations. Basically, we'll look at univariate first and then a quick look at bivariate. With the univariate data analysis, here we can see this, if we have some scores here, just some simple scores that we want to find some statistics with it, our mean, our standard deviation, median. In a lot of cases, it is probably, particularly if they're only after median or interquartile range and such, it's probably easier just to arrange them in an order rather than use your calculator if you're in a rush. But the calculator is very, very useful here because it allows you to cover all of the statistical values all in the one move. So if just open up this one here, and we'll just have a bit of a quick look at these values. Oops. So there's the actual data. I've just created this in a calculator page just by using the curly brackets, the braces, and just typing the values in and storing it by just using control, the bar key as a store, and just giving it a name. So it's probably best to actually give it a name rather than just a single letter. Now, a lot of you are probably more used to actually putting this into a listener spreadsheet. That's fine. That will work fine as well. To guess the statistics for this, we do have some options under our menu here. We can actually just go to our statistics, and our list maths thing, sorry, in a little bit of a hurry there. So under our statistics, list math is number 3. I actually have to use the numbers here because it moves a little bit too quickly for me with this mouse. So you can actually see under those statistics there, the list math, that we can guess the mean and the median there, but it's probably no big deal there. You can see a lot of the other bits and pieces you can do there that's in the IB course as well. But I think for most cases, you're probably better off just going straight to stat calculations, one variable stats, and this will come up. In all cases, you will just have 1 there as the number of lists. So you'll just go OK. And the X list here, because I've actually just created that in the calculator page, it will now be on that arrow. So if I just hit that right arrow, there it is, the scores. Now, that will happen whether you are on a calculator page where you've created it or in a listener spreadsheet page. Usually I prefer to do all the statistics, all the actual presentation of statistics in a calculator page rather than in a list and spreadsheet page because it's a little less messy. You don't really need to fill anything else out here. So the frequency list, this is raw data, so it will remain as 1. You'll see that we will use that field a little bit later on. So if I just press my OK now, there's all of the values that you've got. So I've already had this one on board, obviously. So we can see our mean is 4.8. Our standard deviation, we're using the population standard deviation, as Bozena mentioned earlier on, so sigma x. And you've got all of your other values there that you may wish to use if you're asked to do a box plot. Of course, we've got median sitting in there. So that's that one there. The next one that we'll have that's worth having a look at is just using frequency tables. A lot of people ask, how do we do, our statistics from a frequency table? In the Nspire, we call it a summary table rather than a frequency table. So it's a summary list, which is just the frequency. So if we have a look at some values like this case here, I've just got number of siblings there and the frequency of that. So once again, this time I've just shown you the option of creating it in the list and spreadsheet page, which is probably where most teachers will be asking their students to do it in. But once again, I could have just put all those values in curly brackets, stored it as siblings, then on the next line, put all of these numbers in curly bracket and stored it as frequency. Your choice, really. Now, notice I've only used FREQ here. I can't use the term frequency because that is a reserved calculator name. And it will soon tell you, as you type it in, if it goes upright when you type it in, it means it's a calculator term. So if it remains italics until you press enter, then you know that it's fine to use. So we've just put those values in there, and I'll just go here to the frequency table where I have the data sitting. So here's our siblings and frequency. I'm just going to insert, so Control and the letter I will allow me to put another page in. And I want to put a calculator page in. As I said, I think it's just neater because it's an open screen rather than trying to have it sitting in a list and spreadsheet. So in this case, I want to go to Menu, Statistics, Stat Calculations, and I'm going to do one variable statistics. Once again, as I said earlier, just go straight past this, go OK. Our X list, just use your right arrow on your calculator, and we're going to put in here siblings. But this time, instead of just being raw data, this has been presented as a frequency table. So in here, I've got frequency. And don't fill any of these others out, and we just need to get down to OK. The easiest way here, of course, is just to use your down arrow. You'll notice here that these arrows to the right means don't use the right arrow on the pad unless you want to go inside one of those fields. The other option, of course, is the same as a computer, just using your tab key. Take you to OK and press enter. So there we have all of the values again. So once again, we've got our mean, we've got our standard deviation, and basically all of our other values we may need. So median, and also the values that we can use for creating a box plot. Now, whilst we're at this, I will just quickly insert, I'll just insert a data and statistics page. This is where we must do a univariate plotting. In the exam, it's probably not going to be a big issue here. So click siblings. Now, there is a tendency to race across here and choose frequency. The issue here is that will be a bivariate plot, a scatter plot. So we do have some shortcuts, but if I just go to menu now and go to plot properties, you'll see it says add Y summary list. As I mentioned earlier, we call them summary lists rather than frequency lists. Here, so we're going to add the Y summary, and then in here we'll put frequency. So there is our histogram. Now the way we can change a lot of these, I'm just using the mouse to move across here. We can use our menu and analyze and graph trace, and that goes through them one at a time, just by using your arrow key. To change these here into more appropriate ones if need be. In this case, this is fine. Sometimes you might want to center that. So to make any changes, so just very, very quickly, and we'll look at some of these later on. Here, we will need to go to plot properties. You'll notice most things are shaded out now because it knows we've got a histogram. Histogram properties, bin settings, always choose equal bin width. And the width, in this case, there's siblings going up in 1, so that's fine for us. The alignment is where you want to start. Now, you may want to start here. You may prefer to have that centered underneath. So you may want to just type that in as 0.5, and that will give you the values sitting exactly underneath. That's your preference, really. That's for teaching rather than in the exam. And then we can just mouse across. Notice the nice use here of square brackets and round brackets to show what's included and what's not. So that's just doing a histogram from a frequency table. So just moving back now to our grouped data. Once again, I'd be probably steering a little bit clear of trying to do too much here with your group data. All of this information will be available to you. You'll be sent information of where to get access to all of these files. So don't panic if you miss some of these things. So this one here, if we do have continuous data, so we've got height, say, going up in widths of 5, so 150 to 154, 155, and so on. And I've just put in here middle height. So we can't put these values into the list, so we've got to do a middle height. That's a normal procedure anyway, particularly if you're doing things by hand. There's the frequency, and we'll do it exactly the same way as we did the previous ones. So we'll just go in here. Once again, it tells you statistics, stack calculations, and so on. We'll choose M height, frequency, and once again, we will just go through and just cruise through here and work out what's going on. Now, the other thing here, these statistical measures are only estimates as the raw data hasn't been used. So really, with the advent of the computer or the calculator statistical functionality now, raw data is probably the best way to go. By hand stuff, this is fine, basically, to work with. Now, once again, if you do want to go and change any of this, if you do want to do some plotting somewhere along the line, particularly if you're teaching leading up to the exam, the bin width here, of course, is the width of our groups. So that's in 5, and our starting point we can just put in as 152, which was the lowest we had. So it was basically 152 through to 157 and so on. So we can go through and just make those changes so it actually makes some sense. So that's just using your frequency tables. So hopefully there's not too many issues there. Once again, all of the instructions are sitting here for you. The bivariate data analysis, we'll just go through a couple of things here very, very quickly. These are similar type questions that you will get on the actual exam. So here we've got someone measuring the humidity at 10 different distances from a pond on a bright sunny day. So they've got a little humidity meter and they're measuring the distance. As you would imagine, the further you get away from the pond, the less the humidity will be as a percent. And notice here we've got X and Y, so we will answer our answers in terms of X and Y rather than using the variables distance and humidity when we come to the final answers. So you've been asked to find the Pearson's product moment correlation coefficient. One quick little thing here, Brzena mentioned the use of OS 4.0. We have an option there under the data and statistics page, and I'll show it to you later on. It's probably worthwhile not switching that one on, and I'll explain to you the reason why. Then it asks you to give the equation of the regression line. So if we just go back to some of our data here, and we'll just have a look at, so this is a distance and a humidity. So basically I've just entered these into a list and spreadsheet. As I said, it's probably the way most people will go rather than putting it into the, basically rather than putting it into a calculator page. Now, your option, you've got a couple of here. One, you can go through and do a bivariate analysis, in other words, 2 variable statistics on a calculator page. Alternatively, if you're just looking for the equation, then we can just plot this. So if I just go Control and I, that's just a shortcut of putting another page in. You've also got the options of Control and Dock, which adds a page, or you can go to the home page and select the icon. I kind of use Control and the letter I all the time. So I'm now going to put in a data and statistics page. It says click to add a variable. If you're in a hurry, you can just use your tab key and it will give you all of the choices. So in this case, we're going to put our distance is our independent variable. And up here, this is bivariate data, so I can now just click on this one and humidity. So there's our plot, and they've asked us to come up with a regression equation. Now, I'll quickly go over something here. As I said, your choice as a teacher. Under settings, I can click on diagnostics. This display digits is the number of digits that we've got set on our main screen right at the start of our settings, which by default is 6. And I'm just going to go OK here. If I want this to be on all the time for now and forever until I make a change, I would choose Make Default. So I'll make default. It's not going to make any difference here. So I'll go OK. Now, to get the equation, we'll just go to Menu, Analyze, and Regression, and show linear mx plus b or a plus bx. In statistics modelling, a plus bx is the preferred one, but I would say that the majority of you will stick with mx plus b, the most familiar one, and it will give you the same result, so it is no big issue. I'll stick with mx plus b because it is the most common one that is used by teachers. There's the regression equation. So that's nice and fine. In most cases, you'll be given hints, probably to 3 significant figures, so you'll need to write some of these things down. Now notice, by putting this diagnostic on, it automatically puts R squared on. And a lot of teachers may think, and students particularly, will think, oh, that's fantastic. R is just the square root of that. Well, the answer is, yes, it is, but it could be positive or it could be negative, and we don't want to throw any more hoops in front of the students, particularly under exam conditions. So I would probably leave that off. In this case, it is going to be negative, and if students just take a square root of that, of course, they'll more than likely write down the positive value. So once again, the way you can do this is just Control and the letter I. We'll put a calculator page in. Once again, I like calculator pages for doing all of this statistical analysis. We'll go into statistics, but this time it is 2 variable statistics. Our X list is our distance, our Y list is our height, and this is just going to give me the statistics. I really want to have the regression, so if you're asked for any statistics here, generally not asked for these. Normally you would be doing this for 1 variable stats. So back to our menu, statistics, and we'll do our regression here. And by doing our regression here, I'm putting distance, humidity. I don't need to do anything else here, so don't worry about what numbers are sitting in there. Just go OK. And that will give you the R value. It will give you the M value, the B value, and also gives you the R value. And as I mentioned to you, if you try to shortcut it and just take the square root of the R squared that's given to you automatically if you choose diagnostics on, then we do have this issue of whether it's positive or negative. So just now, some of the things you will be asked, you'll be asked to use this regression equation. So here they've asked us for our R value, and they've asked us for the equation of Y on X. Once again, 3 sig figs if they're asking you for that. Generally, you can give more, but 3 sig figs, basically, if they ask for that, try and stick with that. Then they'll ask you to use this regression equation to predict the humidity at 3 metres. In other words, a substitution. So once again, I've highlighted here, we're going to be given method marks, working marks, and answer marks. So you'll need to show some of the substitution in your workings. Don't just put down computer speak. So in this case, on your calculator, you can just take these values, take the full 6 digits there, put them in, substitute 3 in for the X, and get your value. A little bit more upmarket, you can press the VAR button, which is variable button. Because we've done a regression, there is a regression equation automatically stored that uses these values, and put a 3 in there and it will give you the value. So this is using function notation. The only problem here is if there's multiple marks for this, this is a little bit computer speak. I'd be a little bit wary of that. Play safe and just do a full substitution. Now, Bazina, do you want to go back and do some of yours so we don't run too short of time?
Yep, I would love to do some stuff for high-level math now. I'm on, so I need to share my desktop. And I will start with the Poisson distribution. So it indeed is just high-level math stuff because this distribution is only taught in high-level mathematics. And I've chosen this example and show how to use the Nspire efficiently to get the answers. So the number of industrial injuries per working week in a particular factory is known to follow a Poisson distribution, and we know the mean is 0.5. Find the probability that in a particular week there will be less than 2 accidents, more than 2 accidents, and in a 3-week period there will be no accidents. And they also ask to find the mode of the distribution. I will put a new problem because I have it done just in case something doesn't quite work. So what I would do, I would say that we can actually store our mean as use lambda, so I would use L. So we know that this is our weekly mean. And then we go to menu probability distributions, and we want Poisson CDF, because we need to find the probability less than 2 accidents, so from 0 to 1. So I can put L now because I already defined this variable, and I go from 0 to 1, and then it gives me the answer. Again, I can see it's only 2 significant figures, so I would need to actually change the document settings if I want to display more and want to actually make the changes myself. So that's one way. The other way, of course, is going up and bringing it down. No matter what float we are in, it will always do it anyway. So that was the first question. So if we look back at our question, we want less than 2 accidents, so we've got the answer more than 2 accidents. So as I'm saying, I will now need to actually do, if we want more than something, we know it goes into infinity, so we need to go 1 minus, and that students, of course, need to write things down on their sheets just in case that some of the calculations are not quite right. And again, I can put L here and then go from 0 to 2, and then we get the answer. Now, the other question was asking in a 3-week period there will be no accidents. So because I predefined my L, so now I can go to Poisson PDF this time because we want just no accidents. So that's PDF, and this time I would sell my lambda is 3L because we go over 3 weeks, and then I put 0, we want no accidents, and we get the probability. If the question is asking for mean, I would need to have a look what is happening with the probabilities. So what I can do, I can use Poisson PDF, and again, in this case, we had the same mean. However, I could use the curly brackets and just get some values at the same time. We don't really need many because we can quickly see what's happening. The first probability is already 0.6, which is more than 5, so it's not possible that there is any other probability value greater than that. So at the mode, I see the mode of the distribution here has to be this. If I now go up here and change that, let's say, to 3L, so over 3-week period, of course, I can see that this time the mode of the distribution is 1 because that's the highest probabilities. And also the first two add to more than 0.5, so there is no problem with that. We could also sketch it, so we could go and I will show how I did it because it will take a bit too much time. So of course I don't have to have heaps of values because it could go into infinity, but the probabilities become really, really small. So we say that's my X value, that's the probability, and in this cell I just use Poisson, and I put 0.5 here. I could have put L, comma, X, and it will ask whether that's variable reference on column, so you choose variable, and then we get the values here. And that can also be sketched. So in this case, we can see that the mean is this highest value. But if I go and change this to 1.5, it will override those things. And then I can see that this time the mode is 1. So that's something students can do quickly in the exam conditions, and that's the effective way of using the calculator. Now that was Poisson distribution. The other question I would look at is the continuous probability distribution, which I start with the question. Again, it's only high-level maths. The probability density function is given by a piecewise function. The first is a quadratic we defined. The second has the k unknown and 0 otherwise. So what we want to do here is find the value of k, sketch the graph of the distribution, find the probability that x is less equal to 0.7, and this is the hardest part, to find the interquartile range. So if we deal with questions of this type, we do want to use actually the piecewise function notation. So first thing I did actually to solve this problem, we calculate the area from 0 to 0.5. Since this is just a quadratic, we know it's 0.6. We find the other value, which is 0.1 to 5, and then we use the numerical solve to get the value of k, which in this case is 4. Now, as I said, to sketch the graph using the piecewise function, if I again insert new graph page, so we would need to actually use the piecewise function entry. And this is really important because if we do so, we can do all other calculations in one go, and the calculator deals with these questions really well. So we go 0, and we need to enter between x and 0.5, and then we know our value of k, which is 4.8 times 1 minus x, and we need to say that this time we go for a calculator. It doesn't matter whether we have 2 equals or just 1 equal, as the function should be 1, but it will do it anyway. So it will work 1. So we call this function f2. It's only a small diagram here, but it doesn't matter. However, now if I enter another screen, the calculator screen, and I called it F2, I can check a few things. I can use the numerical integral and see whether actually I got it right. So I go 0 to 1, and I called my function F2. So I can put F2 in x, dx, and it gives me 1. So that is a pretty good answer. So that's the way of checking that. And of course, we can play with the window to have it seen better on the calculator. Now we can then find the probability using either the graph going 7.04, or we can, again, in the calculator screen, we can just go from 0, the probability that's less than 0.7, so we put 0.7 here, and we don't need to worry that it's a piecewise function because it is defined this way, so the calculator knows about it and will give us the correct probability. So it's in graph screen, but the function was defined as a piecewise function, and you could do the same in the calculator screen as finding the area under the graph. So the other part of the question was find the interquartile range. So that's a bit trickier. So we know that the area from 0 to 0.5 is 0.4. So we know that the first quartile will, the lower quartile will lie in this area predefined by 9.6x squared. So we do need to do some calculations by hand there before we can get the value. So we can actually now, knowing this function, I thought I had them done, but it doesn't show. So what we need to do, we need to anti-differentiate 9.6x squared, and then in this case we could use numerical solve because we only expect one answer, and we put our antiderivative, which is 9.6x cubed, because we need to anti-differentiate the first part divided by 3, and we want that to be equal to 0.25, and that is Q1. We could, of course, go back to the graph and try to check whether it gives us this value. The other bit is slightly more complicated, so the students need to do a bit of thinking. So from here to here, the area is 0.4. We want the upper quartile, which is 0.75. 0.75 minus 0.4 is 0.35. So what they need to do, they need to integrate again, but the second part of the equation, which is a bit more complicated. So they need to integrate that, and then have the upper value unknown minus lower value, write the equation and solve it. So when that happens, we can find this other value and so on. So that is how we can use the piecewise function, which is quite handy for doing the questions like that. Now I do one more thing. I look at the concavity and points of inflection, how that can be actually done on the calculator. So I need to open Okay, so let's start on let's have a look on a new document. And what we'll try to do, we'll get the graphs, and let's say that we want to find the points of inflection on the graph of x to the power of 4 minus 2x squared and minus 8. So we sketch this graph. We can't see that much, so let's change some settings to see the graph. Of course, we can do it in various ways, but at the purpose, I just want to see the graph at this moment. So we can see that the graph is concave up here, concave down, concave up, and the question could say, find the points of inflection and determine the intervals where the graph of the function is concave up and concave down. Of course, in a non-CAIS calculator, there is no inflection, so we can't do it this way. The students would have to differentiate and find the second derivative and so on, but for checking purposes, what they can do, they can sketch the graph of the second derivative. So we can get this graph from the template, and our function was f1 in x. So we get the graph of the second derivative, and if we get the intersection where the second derivative, I didn't put the graph first, so try it again. Analyze graph too fast. Intersection. I don't know.
Just try zeros, Božena.
Zeros, that is better. Analyze graph zeros. So that's my graph, and I want 0 here. And then menu, analyze graph, and I want for this graph here. So, of course, they would do it by hand, but they have the ways of checking, and then they can see that, of course, the second derivative changes sign from positive to negative, so it's a point of inflection. It is positive to the left, so the graph is concave down. Between those points, it's negative, so the graph is concave down, and then concavity changes again, and that can be done with other functions as well. So I pass to Russell again, and then we'll see if I have time to look at the finance, solver, and chi-square calculations. Thank you.
Thanks, Božena. We have a lot more material available than we're able to actually show for the day. So you'll be able to get access to this on the internet. That will be supplied to you a little bit later on by TI. Okay, let's just have a look at some normal distribution. I'll move through this one fairly quickly because I do want to have a look at some solids, some volumes of the revolutions as well. So with the normal distribution, let's just take an example of homemade or handmade mud bricks. And the normal distribution here, they've got a mean of 230 millimeters and a standard deviation of 3 millimeters. Find the probability that a brick chosen at random measures between 225 and 235 millimeters. Now, what you'll need to do here is look at the marking scheme as well, just to make sure everything's under control. And you can do a quick sketch to give them a little bit of an idea. Just bear in mind that if you do a normal distribution, then the middle is the mean, and 3 standard deviations to the right and 3 to the left basically will give you the total population of your values within this normal distribution. So 99.7% will be within 3 standard deviations. So it's fairly easy for you to basically work out what's going to happen. Just have a little bit of a quick sketch. I've plotted this. Once again, once you get hold of this documentation, you'll be able to work through this as a teacher or a student. So this is not to be done in an exam. So this is just visualizing the problem here. So we'll go down to how we would actually normally do this on the exam. So calculator page, we've got the menu, probability, distributions, and so on. So basically what we've got here, if I just open up a brand new document here at a calculator page, and this is a normal CDF. So we're under our menu, we'll go to probability and distributions and normal CDF. Now the only time you're going to use normal PDF really is going to be just for doing a plot for visualizing. So a probability density function is just used for the plot. All of your calculations in your calculator page will be CDFs. So the lower bounds, being a non-CAS, it won't write it as negative infinity. The lower bounds, -9 to whatever, you really only need to go to about 10 standard deviations to the left of your mean there, and to 3 and 4 sig figs, you will get there. So it's not crucial. If somehow this disappears, try to remember it. Just put in -100, and you'll be fairly safe, as long as that's more than 3 standard deviations to the left. So in this case, it was 225. So lower bound is 225. Upper bound was 235. The mean was 230. So this was given to us. And the standard deviation, there was 3. And just go OK, and there's your values. Whoops, what have I got in here? Normal, CDF. Whoops, I've made a little bit of a mistake here. I'll just make an error here. It didn't come through with some numbers here, so that was 230. And this was 3. If you want to remember just this syntax, you can just type that straight in as such. And as you notice there, and I noticed Bajena used it before, if you want to grab something that's you've used previously, just arrow up to it and press enter, and then you can just edit it. As long as there's no answer there, you can just edit it. So that's the first little part there of that question. So quite a nice, simple little one there. Now, the next little thing here is asking us, given that 95% of the bricks measure less than V millimetres, find the value of V. So if you're just visualising here, once again, I've just roughly taken it here. You can't do this because you can't do vertical lines. So in the exam, you can't do this, but pre-exam, you can actually just roughly put that in, just using the menu equation. And I've just guessed a value here, just dragged that a little bit. So 0.949. So we want 95% of the bricks. So what we're going to do is just put in a value. Once again, I would just do a little sketch to let the examiners know that you know what's going on. 95%, you should be able to estimate 95% of the total area there. It just puts in a value there, just a little sketch, and just puts V or X equals V or something like this, just to give some idea that you know what's going on. So in this case, this is an inverse normal command. Now, with this one here, inverse normal always comes from this point back. So it's always less than. So don't try and think that you're going to put in an upper and lower and all of this thing. If it is more than, of course, you'll use 1 minus. But in this case, it asks you less than. So just in our calculator page, we just want inverse normal. So menu, probability, distributions, inverse normal. And the area they gave us is 95%, so 0.95. Our mean was 230. Worked that time. And this one was 3. And just go OK, and that will give us our value there. Once again, it will ask to sig fig, so just write this in as 235 if it asks for 3 sig figs. So just going back once again to this one again, if we just continue on. So this is a typical exam question where it's just giving you multiple parts. So it's starting to get a little bit more difficult as we move on. So using the Nspire calculator, what I'm going to suggest you do, when you go into an exam, you start off, open a brand new document, and then when you want to move on to the next question, we're still working within one question at the moment, but if you want to move on to the next question, say question 2, you may have already defined things, and I remember Bajena has defined some functions, whatever she's doing for her question. For the next question, the best idea is just to go to Doc, press the Doc key, and insert problem, and then you're starting a new problem. It's still within the same document because students can only have one document open on their handheld at any one time. So this now, once again, we can store our variables and they don't carry over from the previous one. So when you want to go back now to, say you get up to part D of a question and you get stuck, you move on to the next question, so insert a new problem, and then just using control up arrow, if you wish. On this one here, it's not going too well, so basically I'll just show you a shortcut on the handheld. you can just, when you use the control up arrow, it will give you the thumbnails, and you can just choose the one you want. If you want to go back to problem 1, you've got a little bit of spare time, just go back to that and press enter. Or if you haven't got too many, of course, you can just use control and the right arrow and control and the left arrow. So control and the right arrow will go that way, control and the left arrow will take you back. So you can always go and quickly check. So just looking at this question again that we had, when here we've done our inverse normal. So this one here, they've told you the probability. So L is our length, our variable length of the brick, and they're just telling you that a brick chosen at random, the mean minus this unknown value, W, L is between the mean minus this value and mean plus value is 0.95. So basically, if we're looking at this diagram, just visualizing it, we've got 2 vertical lines here, and we want 0.95 in the middle. So that leaves us with 5%, or 0.05 on either side here. We split that up, and that just gives us 0.025. So from there back is 0.025. So what we want to know, if we want to do it this way, we can take the mean, which was 230, plus this unknown value is less than 0.975, in other words, the 0.025, and come back. And when we do this on the calculator, we will get, so once again, we're just doing an inverse normal, and we'll get 235.88, and of course, that was the mean plus. Similarly, because of symmetry, once again, it's nice to just mention this word symmetrical here when you're talking about this. Once again, it lets the examiner know that you know what's going on and you're just not pumping out answers. So we could take this lower one and come back. So the lower value is 230. The mean minus this magic number has got to be less than 0.025. Put it into inverse norm, and we get this value. So this top one here is doing it where I start up here and use this one and come all the way back. This one here is starting at that point and coming back. And when we subtract them from 230, the mean, one is plus, of course, and one is minus. It gives us the W value of 5.88. A very, very standard sort of question that you will be asked. Quite a nice, simple way of doing it. Your calculator will handle it very, very nicely. This one here, probably time is not going to allow us to go any further. I'll pass back to you, Bozena. I think our time is basically up.
Well,
you may want to quickly...
Yes, probably we'll need to sum up. And I have 2 more activities. One is for finance solver, one is for chi-squared, but I believe it is in the files with all the instructions. So I suppose, yep, we might end up at this stage. Thank you.
Now, Bozena, with regard to that, on the documentation, there will be something that shows the area between curves and also
yes, as well,
the volumes of revolution. So those of you who are watching, you will get a lot of information extra to what we're able to fit in today.
Correct.
Thanks, Bozena and Russell. As our panellists, it was really quite an interesting session, and I hope everyone got a lot out of it. Just for people in the follow-up, an email will be delivered to you the next couple of days, and the links to some of those materials that we were talking about, and also a link to a webinar certificate will be provided. It'll have your name on it and allow you to claim your PD. Now, your feedback's really important to us, so please take the time to respond to the survey at the conclusion of the event so we can continue to improve our webinar series. If you want more information on this sort of topic, then let us know. And finally, thanks for joining us today. It's really important that you listen and learn and develop, and it's really important for us to be able to provide these services for you. And thanks again to the panellists, and that's the end. Thank you very much.